Everyone. Good morning, good afternoon, and good evening, wherever you are. Dear authors and invited guests, welcome to Technical Session 2C. Myself, Harsh Soni, and this session would be moderated by me. So, on behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the 9th World Conference on Smart Trends, Security, Systems, and Sustainability, WS4 2025, London. The ninth edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in London, UK, and the virtual event is being held through Zoom. But that means today and tomorrow. That means 20th and 21st of August 2025. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentation and 3 minutes for the question and answers. So on 10 minutes, I will raise a gentle reminder so you can conclude your presentation on given duration. There is another request to all the participants that you may all please stay connected with us till the closing remarks so we can capture these virtual memories of this conference. If you have any query or any update, you can directly write it to me in the chat box so I can help you out in that matter. Just before we start the session, I'd like to introduce you all to the chair for the session, Professor Balvirdi.
Hello, everyone.
Hello, sir.
Sorry.
Yeah. Yes, sir.
Go ahead, please.
I just give you just a one short intro about you.
Sure.
Yeah. That's it. Okay, so Professor Balvirdi is a director of the Center for Communication Technology Research Group. He had worked as an academic at Open University and Leeds University. His research is in the area of microwave wireless communications encompassing 5G mobile phones to satellite technology. Welcome, sir.
Hi there, everyone. Welcome to the presentations today. We have 5 interesting presentations happening. So I'm looking forward to your presentations. Thank you.
Yeah, thank you, sir. We also have Dr. Swati Nikam with us to chair the session. Swati ma'am, are you there?
Yes, sir. Yeah. Hello.
Yes, ma'am.
Hello, everyone.
Hello, ma'am. So I just give you the one short intro about you, ma'am. Dr. Swati Nikam is an associate professor of the Department of Artificial Intelligence and Data Science Engineering in Pimpri Chinchwad College of Engineering and Research, India. She has total 20 plus years of teaching experience in computer engineering. Her research areas are cyber physical systems, information security, and Internet of Things. She has published more than 30 plus research papers in reputed journals, international journals, and conferences. Welcome, ma'am.
Thank you, sir. Thank you so much.
Okay, so moving forward for the first presentation we have. First, we have Ladislav Pesika, and he's going to present the paper on challenges for assessing data from mobile devices. Dear author, are you there?
Yes, I'm here. Yes, I'm here. Okay.
Yes, you may please start your presentation.
Okay. So I will share it. Okay, can you see my presentation?
Yes, we can see it.
Okay, so I will start. Hello, everybody. I would like to invite you to my presentation called Challenges for Accessing Data from Mobile Devices. It is research made by me, Ladislav Pešička, and my colleague Luboš Matějka from University of West Bohemia in Pilsen in Czech Republic. First of all, the motivation. Nowadays, mobile devices process large amount of data. We are used to streaming film, download films, perceive some big photos and videos, and we need to access these files from some storage. And the nearest most suitable data source may change. Mobile devices can move, change their geographical location, and it's better to use node number 1 or node number 2. And even when these devices don't move, devices can change the technology used to connect the network. It can be 5G mobile networks or Wi-Fi connection. So issues we try to solve, we need to serve a large number of mobile devices located in different places at the same time. It's our goal. When we look at mobile devices, local storage on Android devices and iOS devices, it's similar. In Android devices, there's some internal storage, and for your application ID, all your data are located in data/app ID folder. It's private for the application. You can have also some external storage, SD card, or some part of the storage is used as external storage that can be shared. We can use some backups, and nowadays mostly storages are from capacities shown on the slide. In the case of iOS devices, the situation is similar. There are app containers for app data. They are private for the application, and user manageable files in file application can be managed. So it's local storage, but for us is very big importance network storage. So our mobile devices need some connecting infrastructure. It means Wi-Fi technology of different type, 5, 6, 7, and so on, or mobile network with a different speed and different technology. Network storage we would like to connect can be on-premise, it means in some company or university, or there can be some cloud provider like Amazon, Apple, Google, Dropbox, and others. Difficult task is we need some access protocols or some mobile application. These cloud providers mostly have some native applications. In other cases, we need some API to be used in our application, and there can be some proxy access through some web interface. We try to look about different type of the systems and availability of the mobile clients. And as you can see, Google Drive, Microsoft OneDrive, and Dropbox have mobile client for Android and iOS. And they also give some API like Google API, Dropbox version 2 API, etc. to access in our applications, but other distributed file system like HDFS, Lustre, CFS has no mobile client application, and the only solution how to access these data from mobile application is through some proxy, gateway, WebDAV protocol, and so on. We also mentioned KIF distributed file system. It's distributed file system developing in our university, and nowadays in development Android application. And after the application will be complete, we would like to manage application for other distributed system. So the question is, many different systems in use nowadays were not designed with mobile clients in mind. They just presume stationary clients to be used for accessing data. We can look at the distributed file system and mobile devices in this picture. There is distributed file system from one or more storage nodes. Some nodes contain replica of required data by mobile clients, and there can be less or many mobile clients near the access node that would like to access the data. So issues that must be solved are on client side on mobile device and on server side at the storage side. I would like to start with server side storage. There are many issues that must be solved. Replica management, it means amount of replicas of the data. If many clients want to access this data, so it's important to have many replicas. Amount of replicas can be fixed or dynamic. Level of replication can be blocks or file or volume level, and location of replicas is very important. These issues are discussed in many research papers. We also try to solve some kind of these problems in paper mentioned on the slide. This paper will concentrate on client side. It means how to design client application, identify paper modules in this application, and how to make it reusable for different distributed file system. We will start with Android platform, and maybe sometime we will also develop iOS client. We already mentioned something about access technology. So here is some very short experiment. We have mobile devices located in area Pilsen. It is my city. And we would like to connect to certain nodes. In this example, there will be web nodes, one located in Pilsen, second located in Prague. It's a city about 100 kilometers from Pilsen. As we can see in this picture, in this slide, when we are using Wi-Fi connection in campus Pilsen, it's almost the same if we connect to node located in Pilsen or the node located in Prague from the point of view of latency. Difference in the latency is very short. But if our mobile change to 5G connection, suddenly there are more intermediate nodes and also the latency very differs. So at this time, the storage node located at the Prague has better latency than the storage node located in Pilsen, even without our mobile devices was moving. So we need a distributed file system and mobile client, and we need some data structures that will be stored inside the mobile client about the speed, latency, and load of the access node, and we will choose which access node will be the best in the given case. So we would like to propose mobile client application, how to access distributed file system. There is some specific feature for each distributed file system. We have to implement access protocol by REST API or address API, and it must be made for each distributed file system separately. But there are some general features like storing configuration information, selecting appropriate access nodes that can be done for all kind of distributed file system the same, also data caching management. So we tried to make some structural components of the proposed mobile clients, and on this picture you will see the given components. I will discuss them a bit, and this mobile client will access node of the distributed file system. So first of all is the module for protocols for communication with WS4. As I already mentioned, this must be programmed for each WS4. Second module is access speed measurement utility. This module assists in determining which access node to connect. It can measure speed, latency, and load. And when we can connect to one or more nodes, it helps us to decide which node will be the best. Second, there can be connection-aware module. As we already shown, when we are connected to Wi-Fi or mobile network, it means it could be appropriate to use another access node, so it will help us. The mobile currently switch from one technology to another, and it's time to solve what will be the access parameters. Cache management is also a very important task discussed in many papers. We can use some access strategy like least recently used, delta synchronization, data compression, and log time to live files values if we would like to cache some data or not. Last part is static configuration data. It's essential for accessing distributed file system. It requires at least one IP address or DNS name of the access node to be able to connect to one or more access nodes of the distributed file system. And the last one is dynamic data storage. It can be made by databases like SQLite and measured current access times and other characteristics and help us to choose the access node. Because otherwise, access node is for us the most important part, and how it's behave inside the distributed file system is another issue solved in other papers. Access node role is perform following tasks as shown in the slide: load measurement, redirection of the client to another access node, sending requested data to the client, or data tunneling from inside the diffuser to the client. So, as a conclusion, our research addressed the use of mobile devices in conjunction with distributed file systems. It's essential to consider distinct characteristics of mobile devices. We designed some key structure components, and we are currently implementing Android client for our diffuser file system, and after its implementation, other implementation for HDFS, Lustre, and other will continue. So that's all for me. Thank you and welcome your questions.
Thank you, dear author, for this presentation. Sir, ma'am, do you have any question for this presentation?
Yes, I have one question. Thank you, sir, for the presentation. I have a question like, how do you take care of the security in all these concerns?
Yes, security is very important, and the security is solved at the level of the communication protocol with distributed file system. It means each distributed file system can different kind of security, and it will be implemented as a part of this first protocol for communication with distributed file system.
So which all protocols are planned for security?
There will be some social connection. It means the data shouldn't be accessible through some parts on the way from the server to the client.
Yeah, these are the generic solutions because as it's a mobile device, so it's a constrained device. So you'll have to use the constrained security protocols for the same or algorithms. So have you listed any algorithms or any protocols for this?
Yes, we are in our distributed file system. We are using some we are using some library that is used for data compression and for I don't know how to say it for security.
Yes, I think you'll have to go through the constrained protocols. It comes with the different set of protocols which works in a constrained environment. So maybe as per your requirement of confidentiality or authentication,
Yes,
these will have to be explored.
Yes, it's very important. It's very important part, and mobile devices are limited. About the power management and other issues must be taken into account as well.
Okay, thank you.
Thank you.
Sir, do you have any question?
Sorry, I don't have any question. Thank you. Oh, but please, I'll be happy if you can help me so that I can present, please.
Dear author, there is one more presentation before yours.
You
So I'll
are
just
you are
announce his
the
name.
you are the battery. You are the battery.
Please, I just want to beg, is it possible I swap with the presenter, please? Because we have a board meeting.
Sir,
Thanks.
I can understand, but as per the schedule, we have to follow that, right? I hope you will understand that.
Please, let's just press the cable line.
So I'd like to invite the next presenter. Next, we have Richard Kyung, and he's going to present the paper on chelation stability and radical scavenging activity of flavonoid antioxidants predicting bioactivity through quantum chemical descriptions.
Hi, I'm here as assistant right here. I am actually on my way to settle in a quiet place, so I have recorded my presentation. Is it okay if I play that for now and be back for the Q&A live for a live session?
If you're not able to present it right at this moment, we can allow next presenter. Till then, you can be ready with your presentation. Is that okay?
Yeah, that's fine.
Okay. Okay. Thank you. So, okay. So now we have Oluwasegun Julius Aruba, and he's going to present the paper on data security on audio and image files using hybrid crypto techniques. Dr. Julius, you may please present the paper.
Thank you very much for that, and I'm happy that you also allow me for that. So I'm just going to be sharing my screen right away. Share screen. Where is it again? Okay, share. Okay, share the screen. PowerPoint. Can you see my screen? Can you see my screen?
Just a second, it's loading. I'm not able to see it right now. Yeah, now we can see.
Oh, thank you so much. Thank you, Chair and Co-Chair and colleagues, for this opportunity to be able to present our work that we're actually doing in this space. And it's an opportunity on this. So on this note, I'm going to be presenting on the topic that says security on audio and image files using hybrid crypto signal techniques. And our presentation just goes like this. We're going to be looking at background and motivational literature review methodology results. And we conclude the day with some references. So the world of information today of ICT has been actually advancing sporadically. And as a result of some of this, there has been a lot of risk in transfer of sensitive data. And with this, report from IBM in 2023 actually shows that 95% of different organizations are faced at least one cybersecurity related incident. And out of this, 51% are likely to increase security in terms of investments. And also, on the other hand, according to there's another research article that says 55% of businesses said they would have rather charged customers for the occurrences. And these are many more for some of these occurrences that happens in terms of information with the day and age and time that we belongs to. But when we look at all these study actually have looked at different studies by revealing that while some of the internal team of the organizations are under investigations, and they discovered that some of these data breaches, the attackers and themselves, they revealed that astounding 27% of them. So this reason is why we're presenting our topic that says the study presents a two-tier security approach that may be effectively utilized for safe transfer of data and also transformation and transmission in terms of keyless cryptographics. And this is first thing that we look at in this. And on this note, the study motivation, it's about we're looking at cryptography in terms of decryption and encryption, where we look at the plain text to create a ciphertext, and the recipient can actually decrypt it with the secret message that is embedded in contrast. And also, transmission of data can actually be made secure by combining these two techniques, or three more in terms of hybridizations. And these data are encrypted so that only the intended recipient may decrypt them in terms of the contents when it is being jumbled and concealed behind a curtain. And it does not encourage attackers along the line. And some of the literatures have actually been able to unravel that investigation of least bits, the least significant bit was actually used, and most significant bits were used in terms of pixel values differencing, which is PVD techniques that are used in picture in terms of steganographies. With the mean square errors, there are quite different approaches that are also being used, which is the LSB, the least significant bit, and techniques that are viewed the peak significant to noise ratio, PSNR. And also, there are some studies that also look at the SSIM, which is the structural similarity index, and values based on some of these MSBs. And quite a lot of studies have actually been able to look at different embedments and also cryptography concealment within the line. And our methodology is where we propose that consists of cryptography and stenography techniques, where we look at different algorithms and we'll combine them in terms of the LSB least significant, and the reverse Shamir was actually and Lyman and advanced equations, which is more or less like about hybridization of different algorithms. We now look at this by determining some of the accuracy and combining the various algorithms. And this helps us to be able to see that the outcome of what we've done is actually much more outstanding. And the process we look at is where we collect the data sets, we look at data cleansing, processing, and we look at the AES cryptography for RSA, and also we transpose that to the LSB steganography and encryptions of hiding, and also and we look at different evaluation models of those data sets. So our methodology actually went more further with a block of chunks of size of bits of 126 and the AES encryptions. And we looked at the Regendale algorithm as a symmetric blocks by deciphering some of them, and it uses different keys in terms of 128 bits bytes, and also 192 bytes, and also 256 bytes to convert some of these individual blocks. And this cryptography algorithm was displayed as this process that we have, where we input these files and we convert the input file into binary format. We get the total length of those secret message, and we decipher it by generating an AES key bit and encrypting them in terms of binary array. And we now cipher the text from our AES encryption ID passed down to the RSA, and we generated the RSA public keys and encryption of those plain text, so that the other end of the receiver or within an organization can actually be able to have a very good security stenography encryption method. Keys to be able to decipher their codes. And the metrics that we look at is the peak significant to noise ratio that are too commonly used in metric for assessing the effectiveness in terms of mean square errors of the approaches. And this serves as a foundation for us. And we went further to look at this process of the LSB, the least significant bits, and we repeat the same process: input, convert the message to binary, we convert the images, and also iterate some of these pixels, and we embed them and repeat the same process until we get an output of those images along the line. These are the results that we looked at, which is the figures that actually is very, very outstanding for us. That even in our presentation, in our articles, or we presented those processes in different area, how we model these data sets and also the images. But at the end of the day, the figure we have, which is that of the figure 2 and figure 3, examples of secret image that was concealed with the cover image. And the figure shows that the steganographic images gotten with the LSB, which is the least significant bits. And also, we presented on our table as well in our results that the hidden images of LSB, the values of this PSNR for algorithm, when you compare them, are about 94.1192% when you compare it in terms of the metrics of the output. And also, the image that we also have, which is the figures, it shows that the stego image of the LSB is actually outstanding when we look at the file size, which is the file size of 560 kilobytes compared to every other sizes along the line. And the mean square error was actually 0.000192. So we concluded that most frequently security is provided by using some of this steganography and cryptography, or even both of these hybridized formats involve sharing of a secret key. But in this study, a method that combines cryptography and steganography is a novel with keyless transformations. where it was actually designed by our team, and which increases security to a higher level when you compare to using only the steganography approach alone or cryptography alone, combining them with the RSA models. With all this, it increases security to a higher level, and the system of steganographics approach. It also helps us to be able to differentiate some of these methods using different formats while we compare it to a state-of-the-art algorithms and methods that are used to be able to display these message lengths. And it also helps us to be able to look at the Unicode values for encryptions. And the AES key was actually encrypted using the public keys and RSA. And the RSA key was actually concealed to cover an image using the LSB and F5 algorithm separately when we compare them. And the recipient was able to receive the picture stego, after which the encryption key is decrypted using the RSA algorithm private key to produce the ES. So on this note, we concluded again as well that the hybridization of this encryption algorithm can actually be used in software application, can be used in terms of images, can be used for systems or designs that require exchange of data to be able to secure. And research conducted shows that the F5 algorithm performed better in terms of the LSP, and showing the PSNR 96.98822 with mean square error, which is 0.1353, while we compare it to the PSNR, which is 94.1, and also the mean square error, which is 0000.1920. With this is actually helping us to see that the upgrade that we've actually been able to, it's very, very unique. And thank you for this presentation. And I hope you've been able to, and these are some of our references, and I'm open for question and answering. Thanks so much for this. Can you hear me?
Hi, James.
Yes. Thank you.
A very interesting presentation. My question is, by combining the two different techniques, you're increasing the computational load. Do you know how much more effort the computer needs to do to implement your algorithm?
So now, for in the terms of computer actually, you can, is it in terms of which kind of format of is it you're talking about images, or you're talking about different text or emails, or
Well,
what
for
kind of
example,
formats? So now what we've done,
images are quite,
yes,
as you know, quite
bigger,
bigger. Yeah.
yes. So
We've done a
with what
comparative
we've done,
study.
yes, with our comparative study, with what we did, because we actually compare to state of the art of what we did in our research. So we actually start using this kind of approach, whereby, normally if you're sending an image, let's say you're sending a result of a student or probably a group of image that you don't want people to be able to decipher. So now when we run it through our algorithm, we're able to encrypt it and also minimize or reduce that image to maintain the same quality, so that when we send the deciphering code, encryption code, to whoever is the recipient, it maintains the same resolution, and also it gives them something to be able to work with without jeopardization of an intruder within that network. I hope I'm able to answer you. We've actually been able to implement this in some of our institutions that we collaborated with, because this collaboration is about 3 to 4 institutions. If you look at the authors, were about 4 or 5 of us from different institutions, and we're able to implement this with what we do within the institution as well.
Thank you so much. Thank you.
Thank you. Thank you so
Thank you,
much
Doctor.
for the question.
I have one question. Like you
Yes,
have
please.
a combined already existing algorithm, that is AES and RSA. Now, how do you deal with the attacks?
Yes.
Because AES and
How do we
RSA,
deal with
they are
it?
not.
Say that again. RSA does not. I didn't hear the last question.
Yeah, because these are already existing algorithms, so and you are combining it. So how do you take care
Yes,
of the
we're
attacks?
hybridizing them.
Yeah.
So how do we prevent the attack? Is that what you're saying?
Yeah. Yeah.
Okay. So now, if you look at the hybridization of what we've done, you'll see that it's not only 1 or 2 or 3. is not only one that we're actually looking. We look at the three. And when you look at the F5 algorithm, it actually prevents more in terms of the hybridizations. Unlike now, how do you prevent the attack? Is that we actually set the code for deciphering, where we encrypt that code, and nobody can actually have that encryption except the receiver or the people who actually own the files or the projects that can be able to decipher it with the help of the encryption of RSA code that we generate and submit to them. So that's how we are able to minimize that without an intruder able to be able to deceive, because the code can be generated. Now the system, the algorithm generate the code for us, and that is what we share. And this can be permutated or can be jeopardized by any individual in this presentation in terms of the results. Thanks. I hope I'm able to answer your question.
Actually, but the existing attacks are already there. I mean, although it's system
Yes.
generated, but then prevention, how do you take care of that is not yet clear. I mean,
so how do we prevent? Now, for example, you can't say you want to send the same file with the same email, for example. How do you prevent it? You can't send the same file with an encryption. You have to send it through another medium. Maybe you want to send it through a text, or maybe you want to send this deciphering code through maybe a mobile number or something like that instead, or maybe a WhatsApp chat or something like that. That is only for that person that can be able to input that code to be able to decipher, whereas an intruder can be able to intrude into that. So that's one of the mechanisms that we're able to put in place. For example, now, let's say your exams that you set and you're able to encrypt it and you run it through this now, exam questions. Now, when you are sending that to an organization or to moderators, you don't want to send it with the password in that same email. No, you send it through maybe a WhatsApp or via text, the password through what they can use to be able to encrypt, to decrypt, to encrypt that files that is already decrypted. So security measures is actually taken in that way, except you have the access code. You can't be able to do anything you want to do on that. That's another example as well. In terms of images, maybe you want to send an image, a large files that we've actually been able to run through using different methods and be able to condense that image. It can go through as zip files. By the time they're decrypting and encrypting them, they start entering the input of those codes. So that way also is also another way of how we will be able to prevent attacks and also anyone, an intruder from that. Thanks so much.
thank you, Doctor.
Thank you.
Thank you, Doctor, for your presentation. Now I'd like to invite the previous presenter who, like Richard Kyung, instead of Richard, So-Min Lee, she's going to present the paper. Dear
Yes.
author, are you there?
Can I share my screen here?
Yes, you may, please.
Do you guys see it?
Yes, we can see it.
Right. Hello everyone. My name is So-Min Lee, and today I'll be presenting our study on chelation stability and radical scavenging activity of flavonoid antioxidants. This research was carried out in collaboration with Dr. Richard Young, who is not present here today. Over the course of this talk, I will share why flavonoids are so important, how we analyze them using computational methods, and what we discovered about their antioxidant performance. The ultimate purpose of this presentation is to show how quantum descriptors can allow us to predict biological activity in advance. Instead of relying on slow experimental testing, we can use calculations to quickly identify which molecules are most likely to perform well. This approach not only helps us understand natural compounds like flavonoids, but it also provides a framework for developing new therapeutic agents. Reactive oxygen species, also known as ROS, are chemically reactive molecules such as hydroxyl radicals, superoxide anions, and hydrogen peroxide. At normal levels, they have important physiological roles, including regulation of cell growth, apoptosis, and immune defense. However, when ROS accumulate in excess, they lead to oxidative stress. This damages proteins, lipids, and DNA and creates a cascade of harmful effects in the body. Oxidative stress is strongly linked to human disease. It accelerates the progression of neurodegenerative disorders such as Alzheimer's disease, contributes to vascular damage in cardiovascular diseases, and promotes the development of certain cancers. Because of this broad effects, the ability to neutralize ROS is one of the central challenges in modern medicine. And this is where antioxidants come in, and among them, flavonoids stand out as some of the most promising natural molecules. Flavonoids are a major subclass of polyphenols, which are compounds rich in hydroxyl groups. The presence of multiple hydroxyl groups gives them strong redox potential and allows them to donate electrons to neutralize free radicals. Beyond their antioxidant properties, flavonoids also have anti-inflammatory and antimicrobial activity, making them multifunctional in both plant biology and human health. In terms of diet, flavonoids are widely available. They can be found in fruits such as apples and grapes, in vegetables like onions and celery, and in drinks such as tea and cocoa. Their abundance in food makes them accessible, but their molecular diversity means not all flavonoids perform equally well. This variability is what motivated us to systematically compare their antioxidant potential through computational descriptors. There are 6 major subclasses of flavonoids that differ in structure and activity. First, flavonoids are found in celery and parsley. Isoflavones are abundant in soy. Anthocyanidins provide the red and purple pigments in berries and grapes. Flavonols are common in citrus fruits. Flavonols are concentrated in green tea and cocoa. Finally, flavonols are present in onions and apples. Each subclass has a distinct arrangement of hydroxyl groups and double bonds, and these differences strongly influence their electron donation ability and binding interactions with ROS. This structural diversity is precisely why some flavonoids are outstanding antioxidants, while others are relatively weak. To evaluate them fairly, we needed to define clear and consistent descriptors that could serve as objective measures. The aim of our research was to identify reliable quantum descriptors that predict antioxidant capacity. We focused on 3 main measures. First, binding energy, which tells us how strongly a flavonoid interacts with reactive oxygen species. Second, the HOMO-LUMO gap, which reflects how easily a molecule can transfer electrons. Third, charge transfer, which measures how much electron density can be donated during an interaction. Together, these 3 descriptors form a predictive framework. They allow us to compare flavonoids in a way that is not biased by experimental variability. And more importantly, they provide a toolset that can be applied beyond flavonoids to other classes of natural products and drug candidates. This makes them highly relevant for pharmaceutical development, where predictive modeling is increasingly important. Our computational workflow had 4 key steps. First, we constructed molecular models of the flavonoids and of the relevant reactive oxygen species, including hydroxyl radicals and the biologically relevant doublet states. Second, we optimized the geometry of each molecule using density functional theory with the B3-LYP functional and the 631G basis set with depolarization, ensuring accurate electronic structures. Third, we included solvation effects by applying a polarizable continuum model with water as the solvent. This step was important because it allowed us to approximate physiological conditions rather than studying the molecules in isolation. And finally, we carried out electronic analysis, calculating orbitals, charge transfer values, and spin densities. This pipeline provided us with a consistent and biologically realistic set of results. Binding energy is a direct measure of how strongly flavonoids interact with reactive oxygen species. We corrected all binding energies with 0-point energy to account for the fact that molecules vibrate even at absolute 0. Lower binding energy values indicate stronger interactions, meaning more efficient neutralization of ROS. Our results show that flavonols and anthocyanidins had the strongest binding with energies around -5.1 electron volts. And isoflavones and flavanols had weaker binding, closer to negative 3.8 electron volts. The difference was linked to structural features such as the presence of adjacent hydroxyl groups and extended conjugation. These features stabilized the interaction and made the molecules more effective scavengers. The thermodynamic stability is another critical factor. Flavonoids turned out to be the most stable subclass with the optimized energy of about 150.9 kilojoules per mole. However, stability alone does not guarantee biological effectiveness. A molecule also needs solubility in order to be bioavailable. Flavanols, for example, show the high dipole moment around 1.8 dBi, which means they are highly soluble in water. Flavanols also had strong polarity with dipole moments around 1.76 dBi. These results highlight an important trade-off between stability and solubility. In drug development, the most effective compounds are not always the most stable, but those that achieve a balance between stability and bioavailability. When we compared all 6 subclasses across the 3 descriptors, flavanols and anthocyanidins consistently stood out. They combined strong binding energies of about negative 5.1 electron volts with small HOMO-LUMO gaps between 2.4 and 2.6 electron volts and high charge transfer values around 0.45 electrons. By contrast, flavanols and isoflavones consistently performed worse across all measures. Flavanols had high solubility but weaker binding energies. These findings align with what we already know biologically. For instance, diets rich in berries, which are abundant in anthocyanidins, are associated with strong antioxidant effects. Our computational results help explain these real-world health benefits at the molecular level. From these findings, we were able to identify common mechanistic features of the strongest antioxidants. First, they had a high density of hydroxyl groups, which provided multiple sites for electron donation. Second, their HOMO-LUMO gaps were consistently in the range of 2.4 to 2.8 electron volts, a range that supports efficient electron transfer. Lastly, they combined negative binding energies with high solubility, which means they were both reactive and bioavailable. Also, extended conjugation allowed them to stabilize radical intermediates, preventing chain reactions of oxidative damage. Together, these characteristics form design rules that can be applied to intentionally create new antioxidant molecules with predictable outcomes. These insights have clear pharmaceutical relevance. Flavanols and anthocyanidins with their strong activity and adequate solubility emerge as leading candidates for therapeutic use. They have potential applications in treating conditions where oxidative stress plays a central role, such as cancer, cardiovascular diseases, and neurodegeneration. One specific example is quercetin, a flavanol found in onions and apples, which already shows promising neuroprotective activity. By applying our predictive framework, drug developers can optimize molecules like quercetin or design entirely new derivatives with even better balance between stability and solubility. This creates a path toward rational development of antioxidant drugs, reducing reliance on trial and error experimentation. To conclude, our study demonstrated that binding energy, HOMO-LUMO gap, and charge transfer are reliable predictors of antioxidant activity. Among the 6 subclasses we examined, flavanols and anthocyanidins were the strongest performers. And flavanols and isoflavones were consistently weaker. The key lesson is that drug development should focus on achieving a balance between stability and solubility. By doing so, we can identify and design compounds that not only bind strongly, but also bioavailable. This framework provides a blueprint for rational antioxidant drug design and offers new hope for addressing diseases driven by oxidative stress. I would like to acknowledge my co-authors and our institutions for supporting this work. And here are the key references that guided this research. And thank you so much for your attention, and I will be happy to answer your questions.
Hi, I've got a question for you. You say that flavonoids and anthocyanidins outperform others. By how much do they outperform?
Could you repeat the question, sir? I think I
Yeah,
had a bit of.
you say that flavonoids and anthocyanins outperform others. By how much do they outperform?
Oh, okay, that's a good question. In our results, flavonoids and anthocyanins consistently showed stronger performance compared to other antioxidants. So, for example, their binding energies were more negative, meaning they form more stable interactions with reactive oxygen species, and their homolymph gaps were much smaller, which allowed more efficient electron transfer. While I can't give a single percentage number since the exact value is dependent on the molecules tested, overall they scored at the top range of our models and outperformed others by a clear margin, both in stability and radical scavenging ability.
Right, thank you.
Okay, thank you.
No questions from my side. Thank you.
I have another question. Have you done any clinical studies yet, or is still to do?
Oh, we haven't done actual clinical study yet, but actually I think this was written on our discussion section, but I think we will be that will be the next step for this research, to do a clinical
Yeah.
research. Yeah.
So you'll probably need ethical approval for your studies, I take it, yeah?
Yeah, I think so.
Great. Thank you so much.
Thank you so much.
Okay, thank you for your presentation, dear. Now I'd like to invite the next presenter we have. Just a second. Yeah. So next we have Shafisho Joseph Safara, and he's going to present the paper Investigating Gender Bias Using Artificial Intelligence Classification Models and on RAVDESS datasets. Dear
Thank you
author,
very
are you
much.
there?
Yes, I'm here.
Yes, please you may present the paper.
Thank you very much. I am going to share my presentation. All right, please confirm if you can see my presentation.
Yes, we can see.
Thank you very much. My name is Joseph Safara, all the way from South Africa. I'm going to present the paper titled Investigating Gender Bias Using AI Classification Models on RAVDES dataset. This is a dataset that contains speech, audio recordings of people speaking in different emotions. All right. Now, this is, okay. This is my outline. I'm going to go through the introduction, some of the scientific contributions, the problem statement, solution, and the results of the paper. Now, AI classification, this AI classification models are increasingly being deployed across wide array of sectors, becoming fundamental tools in decision-making processes that impact individuals and society. These models are utilized in critical applications such as recruitment processes, healthcare, financial risk assessment, criminal justice systems, and educational admissions, demonstrating their passive influence. However, a significant challenge arises from the susceptibility of these models to biases, which can lead to outcomes that are unfair to others, that are discriminatory, and ultimately harmful to individuals and specific demographic group. Now, these biases raise profound ethical and societal concerns, necessitating careful attention and proactive mitigation strategies. Now, in the paper, we are providing some discussion on gender bias for several domains. And also, we evaluate the impact of gender mitigation on the trained classification models. And also we proposed the bias mitigation technique for pre-processing step. So as the presence of bias in AI classification modules is a reflection of broader societal challenges. As AI systems become more integrated into our daily lives, the potential for bias algorithms to perpetuate and even amplify existing inequalities become a pressing concern. This results of unaddressed bias can erode public trust in AI modules and even hinder the realization of its potential benefits. So in the paper, the aim is to investigate the impact of bias in AI models using the AIF 360 toolkit on the roughness data set of emotional recognition. The AIF 360 toolkit was developed by IBM as an open source library that helps us to understand and mitigate bias in any AI models. This about the dataset. So the roughness, we acquired the roughness dataset. In the dataset, it contains 24 actors speaking the same sentence in a neutral North American accent. So the utterances consist of 8 emotions: sad, happy, fearful, angry, disgust, calm, surprised, and neutral expressions. Now, the dataset also contained the songs, but we didn't use the songs in the paper. And in addition, the dataset consists the gender of those people of those actors. So on the recordings, we extracted acoustic features using the Librosa library. This is a Python library that we used on the dataset. So we extracted the fading MFCC coefficient dataset. Now this is the like a feature set that we are going to feed into our machine learning modules. Now, yeah, this table just summarizes the data set by gender. So, yeah, you can see that this is a small data set, so that's hence we opted for a machine learning modules, not the deep learning modules. Now, on the paper proposed AI bias architecture illustrated in this figure. The architecture describes a flowchart depicting the process of ensuring fairness in AI systems. It starts with raw data which undergoes a discrimination data unit test. If the data set metric indicates potential bias, a pre-processing algorithm is applied. Otherwise, a standard pre-processing is used. The data is thus split into testing and training sets. The training data is used to train the classifier with an option for in-processing algorithm. Yes, in-processing algorithm or standard training. The classifier accuracy and discrimination are tested, and if the data set metrics show bias, a post-processing algorithm is applied later on. If bias persists, the system is retrained. External interventions can occur at the raw data stage, and the final model is deployed after fairness is deployed later on. Then this data aim to mitigate bias and promote fairness in AI decision making. The focus of the paper is conducting experiments on the pre-processing algorithm, the one shown in green on the architecture. Now, this is the module that we have used to build a classifier. So we used the logistic regression module, which is a machine learning module used primarily for binary classification. So logistic regression is a data analysis technique that uses mathematics to find relationships between data factors. It then uses those relationships to predict the value of those factors based on the other. So yeah, normally this module was used for the binary classification, but now it can be used for multi-classification modules. So we use the scikit-learn Python library to conduct experiments and build the classifier. So in the paper, we also show some of the hyperparameters that we have tuned, how we have tuned the classifier. Now, the accuracy of the machine learning modules can be affected by different factors, including the quality of the data, pre-processing techniques applied on the data, and hyperparameter tuning of the module, and the evaluation method applied. The data was split into 90% for training and 10% for evaluating the logistic regression model. So the test data set consists of 49% females and 51% males since the data split occurred randomly. The objective here is not to predict the gender, but predict the emotions after bias mitigation. So the data included extra column for the gender attributes for each speaker. The logistic regression model was trained and obtained accuracy of 60%. This is before bias mitigation. So gender bias mitigation refers to a technique used to reduce unfair outcome produced by the model. One significant category of this technique is pre-processing methods, which addresses bias by modifying the training data before it is fed into the model. Reweighing is the selected method applied in the paper. Remember, this method comes from the .aif 360 library that we have used. Reweighing is a bias mitigation technique that works by adjusting the weights of individual data points in the training data set. The core idea is to give more importance, higher weights to instances from underrepresented groups and lesser importance to instances from overrepresented groups. This rebalance aims to ensure that the model learns more equitable representation of the data, thereby reducing bias in its predictions. So we set the gender column as input to the reweighing method. The aim is to reduce the chances of the model predicting a certain set of emotions to one gender. Now, these tables show the accuracy of 66% after bias mitigation. So we have the method reduces bias in the module by 6%. Hence, this results show the importance of bias mitigation using the reweighing as a processing step, as proposed in the architecture. Now, in conclusion, the paper investigated the impact of gender bias in AI classification modules. The paper focused on emotion recognition classification task using logistic regression module. We discussed the two types of bias emotions recognition, the bias in facial and in speech emotional recognition. In the paper, we proposed the use of reweight technique on a pre-processing step to mitigate gender bias. We trained and evaluated the module on the Rafters dataset. The module after bias mitigation was improved by 6% on the accuracy. Now, the future work will focus on other domains to detect and mitigate AI module bias. We're also detecting bias on in-processing and post-processing steps. These are the ones that we have not used in this paper. Then again, the future will investigate the bias mitigation on a deep learning module such as CNNs and RNNs, and also applying fairness metrics, including the equal opportunity difference, demographic parity, or disparate impact. This we have not done them in this paper because this is a multi-class classification. So to do this, we certain custom metrics need to be created to apply a fairness metrics on a multi-class classification. Now, this some of the future work that we'll focus on. I thank you very much.
Thank you, Joseph. Yes, ma'am. Do you have any question?
Yeah, thank you, Mr. Joseph, for your wonderful presentation. My question is, can you elaborate on that fairness matrix? I mean, what all will be the parameters?
All right. On the fairness matrix, this is where you look at the input to the, like, after you've done the bias mitigation, right? Now at the end you need to continue and measure the fairness. How fair is the model, right? So the aim here is that the bias mitigation, the aim is to reduce the bias in the model. Then after that, the fairness metrics need to be like developed or created. These are some of the that are just listed here. That can be some of the future work that can be focused on. So the aim here is that is just to measure how fair is the model after your bias mitigation. So these are the ones that we have not done in the paper. We listed them as the future work.
Okay, thank you.
Sir, do we have any question for the presentation?
No, I don't have any questions. Thank you.
Okay. Thank you, Joseph, for the presentation. And I'd like to invite the next presenter we have. Next, we have Rosalind, and she's going to present the paper, SHAP Optimized Sample Learning Framework for Cattle Retinal Disease Classification using PCA Transformed RGB Imaging.
Yeah, good morning, everyone.
Good morning, sir.
Yeah, my colleague, my co-author is the Dr. Roslyn. She's not, is unavoidably not present. I, as a co-author, I will be presenting the paper. Before this time around, we have already sent the recorded video to the organizers. We thought that today would not be possible for us. We have sent the video, the recording rather, and we also asked them that if permission we could not be present today, they should use the video for us. But now, by God's grace, we shall be presenting, and in addition to the video that we have sent. So I just hope that you will take the two submissions like that. Thank you so much. Are you people seeing my slides?
Yes, we can see it.
Okay, thank you. As I've said, we are here to present our paper. It's on a sharp optimized ensemble learning framework for cattle retinal disease classification using PCA transformed RGB imaging. As I've said earlier on, is by Roslyn Oluwaseun Ogudokun and Rotimi Williams-Bello et al. Our presentation outlines are like this. We talk about the background and motivation, the research gap, the objectives, the contributions, data set and preprocessing, the methodology overview, baseline versus optimized, our models, the results, our comparative performance, the clinical and practical implications, limitations, conclusion, and references. Background and motivation. Retinal imaging, a non-invasive diagnostic tool for veterinary medicine. It helps detect ocular and systemic conditions in cattle. Few automated systems are available for livestock. Need for lightweight, interpretable AI tool for deployment, according to U et al. 2022, Sai et al. 2023. Come in, please. Research gap. We noticed that deep learning, though is accurate, but is computationally heavy and incomprehensible. Classical ensembles, they are efficient, but often under-optimized. Explainability AI is what we are trying to adopt in this research, combining it with sharp model So it is critical for veterinary adoption. There are limited research which combines grid search optimization with sharp interpretability, according to Rest et al. 2024 and Z et al. 2020. Objectives. The objectives of this study were to develop a robust, interpretable ensemble pipeline, compare baseline and our own optimized ensembles, use SHARP for transparency in feature contributions, validate with real-world cattle retina dataset. The contributions of our work are grid search CVA, optimized ensemble, RF, GB, ET, and so on. PCA transform RGB feature for dimensionality reduction, sharp-based interpretability integrated into the workflow. Deployable lightweight veterinary diagnostic system. The dataset for the preprocessing. Source, cargo, CVD versus non-CVD cattle retina dataset. Binary classes, LD and un-LD. Preprocessing. We resize what we got from the cargo to 120 by 128. We normalize to RGB, flattening. Train, validation, and test. 80 for training, 10 for validation, 10 for test, stratify, split. PCA, reduce 49.152 feature to 150 feature for proper model learning. Methodology overview. Preprocessing, PCA use 150 components. Ensemble model, which is RFGB, and ET, which is soft voting. Grid search CV optimization. SHARP, which involve feature level explainability. Here is our architectural diagram. From the input image to the image processing to the PCA down to the ensemble board, flow to random forest, gradient boosting, extra trees that I've earlier talked about. Then from the ensemble model back to the evaluation, the model training, all together to the sharp. And you know that sharp as a sharply additive explainability model is helping models for proper understanding to the users. It helps all the features that the model needs to be more understood. That is the essence of SHARP. If you are familiar with SHARP, it helps us to comprehensively understand our model. That's why we concentrate on SHARP and ensemble in this research to make the difficulties confronted in using deep learning to reduce it. That is the essence of the architectural diagram. Baseline versus optimized models. Baseline ensemble, which is RF 153, maximum depth is equal to 10, GB 150 estimator, R is equal to 0.1, ET 200 trees, optimized ensemble, RF hyperparameters tuned with grid search CV, and the proposed model show better sensitivity and precision. You can see our result using confusion matrix. Our confusion matrix let us to know that the baseline models, the left-hand side, you can see for the ensemble models confusion matrix, you can see that it gave us the correct 19 LD, 47 on LD, error 34 FP, and 12 FN. If you look at our optimized ensemble models confusion matrix, you can see that we were able to get 24 LD cattle retina feedback, meaning that we were able to have extra 5 more than the one that the ensemble, which is the baseline, was able to give us. It gave us 30, 19 LD, we were able to get 24. And look at the on LD, it gave us 47, but we were able to get 48. We beat the ensemble model by 1. And for the LD, we beat it by 5. And if you look at the error, for the error, it got 34 FP, which is deceiving. That is too bad. And we were able to reduce that false prediction to 29, and we got 11 FN. You can see in both cases, we were able to have a trustworthy, relied upon results. Still continue with the ensemble model and I optimize ensemble model using region of curvature. If you can see for the ROC, for the false positive rate, you see that the baseline AUC got 0.68. We got 0.73, which give a stronger separation. If you are familiar with how ROC works and AUC, you can see that the 0.68 is not having it has a weak separation. Why this one give us a stronger separation, making the unhealthy and the healthy analysis are superb. The metrics table shows that accuracy from the existing baseline model got approximately 73%. Our own got 76.5. We beat it there. AUC 0.68, ours 0.73. We beat it again. False positive was 34, while we reduced it to 29. You know the implication of having a false positive in model experiments, which is very, very dangerous for conclusion, and we were able to reduce that FP to 29. The false negative also, we were able to reduce it from the 12 which is in existence to the 11 that you can see. Sharp explainability. Top pieces had a moderate, consistent influence. It improved trust and transparency in decision, as we have already seen in my previous slides. Using the sharp explainability, we were able to see the comparison between the ensemble and the optimized ensemble. We were able to see clearly the limitations that are being existing in the ensemble. That sharp explainability integrated was able to give us transparency and a trustworthy outcome. Clinical and practical implication, early retinal disease detection, timely intervention, lightweight deployable in farm and rural clinics, sharp ensure interpretability for veterinarians. The limitations in the work, binary classification only. Misclassification persists, especially LD class, as we have already seen. PCA-based features are less clinically interpretable. These are our references. Thank you for your attention. Myself, Dr. Rosley, and the remaining co-author say thank you for listening to our presentation. I am open to questions and answer.
Thank you very much. I don't have any questions for you. It was a very good presentation. Thank you.
Thank you.
Yeah, thank you for the presentation. I have one question.
I'm
What do you
listening.
mean by, you have mentioned about lightweight implementation. So can you focus, can you explain what all methods are being used for that lightweight implementation?
Can you just come again? I can't pick your.
You said in the presentation about lightweight methods. So can you
Yeah.
elaborate which methods are being considered?
As we have already said, our model was combination of ensemble and sharp. Sharp itself is a lightweight model because there are deep learning is not that lightweight. It's heavy. It may computationally heavy. That is why we use sharp itself. Sharp itself is lightweight, making us to be able to overcome all that comes with deep learning, which comes with heavyweight model. But this one being a lightweight model on its own, which is the sharp itself. The sharp itself is lightweight. So there is no more explanation for sharp because in itself it is explanability model, making it lightweight. And that is why we dwell on it to make progress with our experiments. I hope that is clear to you.
Okay. Okay. Thank you.
Thank you, dear author, for the wonderful presentation.
Thank you.
Now I'd like to invite the next presenter we have. Next we have Sarah Alhami, and she's going to present the paper Writer Identification of Arabic Historical Document using a Deep Learning Approaches.
Let me share my slide and you can do your own. Okay, I have removed my slides.
Is my slide very clear?
Yes, it is clear.
Okay. Thank you, everyone. Hello, everyone. This is with you, Sarah Muhammad Al-Hazmi, and today I will present for you writer identification of Arabic historical document using deep learning approach. This is our outline for today. First, we have introduction for this topic, then research question, after that related work, then methodology, last thing results. Introduction. Arabic historical manuscripts are considered in variable culture. These documents can suffer and damage due to many factors. One of the factors is the quality of the document itself may be poor, or the preservation methods bad, and maybe the ink will poor quality. All these factors can cause the problems in determining who write the documents. So, writer identification defined by the process of determining the writer name written by a known writer to well-known writer. Our third Arabic historical document present two basic challenges. The challenge due to the Arabic script itself. The second challenge is due to the nature of the historical document. The first one, the challenge due to the Arabic script. The Arabic script has 28 letters, and these letters are curved, and it's written from right to left. Also, this letter has 4 fundamental shapes based on where it's at. Like here, ba letters. Here was to be isolated, and in the beginning of the word, and this is the shape on the middles, and this is at the ending of the words. And the second challenge, due to the nature of historical scripts, this challenge arises from degradation over time, such as chemical degradation due to the temperature change, or biodegradation due to the living things, or human degradation such as scratches. Let's go to the research question. We have two important research questions. How effective is the deep writer model in identifying writer in Arabic historical document? And how effective is the half deep writer in identifying writer in Arabic historical document? So the main contribution here is to apply the two models, deep writer and half deep writer, on WEHD datasets to identify the writers of Arabic historical document. The related work here was selected based on the relevant to writer identification of Arabic historical document and the newest idea in this field of writer identification. The first paper, the basic idea here is the feature extraction by using scale invariant feature transform, and then followed by dimensionally reduction through the principal component analysis. After this, the random sample from the first step are clusters using k-mean algorithm, then trained by using ResNet20 networks. After training, this cluster convert into vector using VLAD. VLAD is vector of locally aggregated distribution. To determining the similarity, they use cosine, distant, and support vector machine. Also in this paper, there is a private historical data sets called Balamand was built. As we notice here, in the result, the perception is good, but the recall and F1 in this study, not that much of good, and that indicate many false positive results. Let's go to the second paper. The second paper is apply on the private datasets, but it have new idea and it's a good one. The basic idea here is to combine the top key result from multiple models and then analyze the intersection between these models. By using this idea, the top one accuracy raised from 88.3 to 84.1%. So let's go to the methodology we applied here. First, we will talk about the data. The data, it's called WEHD, which stands for Writer Identification of Arabic Historical Document. This data is gathered from National Library in Jerusalem and Islamic Heritage Project. This is available online, and this data is unbalanced, having the problem with unbalanced data. So we apply data augmentation technique. In this experiment, we apply many processing thing, and we apply many things like resizing image. We resize the image into 128 pixels. We use this specific measurement to ensure there is no important information is lost. This also can help us to extract 133 pixels from multiple locations in the same page. This will increase the diversity without damaging or cropping anything. The second one is binary thresholding. Every pixels more than 127 are converted to 255 white background and the rest to black. Label encoding. Each image is encoded in an numerical format. Split data using straightforward shuffled split. We use this to maintain the appropriate distribution of the different categories in this data. Data augmentation. We apply it only on the training sets. We use techniques like cropping or changing the contrast and rotating. We use this to focus on the unique characteristic on the handwritten itself, not on the details of the image. Here, normal initialization conventional layer. This the resolve RLU activation function. L1 and L2 localization in the fully connected layer. It's used to increase the model generosity capacity. We use also early stopping to end the training after a specific amount of epoch if the metrics not improve, and reducing the learning rate. When the measurement does not improve, the learning rate will automatically decrease. Model checkpoint. We use it to get the best version of the model. This is example of our data, as we notice here. The first page, and this is the second page. Let's go to the methodology. This is the methodology of half deep writers. First step is input data. That's mean the training and testing and validation. For the pre-processing before the feeding the image into the network, of course, we need to pre-processing, like remove noise, resizing, CNN layers. We have here 5 conversion layer. This used to extract the features. Max Boolean after conversion layer to reduce the dimensionally. Fully connected layer. here, F6 and F7, used to convert the features into numerical representation. The last thing is out and softmax. This used for classification. Feature extraction. The unique feature of each writer are stored to identifying the writers. This is the methodology of the deep writers. As we see it have the same, but the difference here is the double path. And it have some layer. This is the output of the two CNN stream are combined here. And then we softmax classifier for the final writer identification. This is the result of half deep writers. As we notice here, with the learning rate 0.002, it has the best accuracy in test accuracy. This is the result of deep writers. As we notice here, 0.002 learning rate. It got the best test accuracy. And for future work, deep writer and half deep writers will apply to the Arabic data sets such as CAT or Infinity. Inshallah, we will go to the English also data sets. In the future also, we will use the combined techniques with deep writers and half deep writers. The integrations aim to leverage the advantage of CNN architecture in additional. We accept to apply combined to the output of deep writers model will improve the result and the accuracy. And this will solve also the poor generalization in any structures, inshallah. Thank you. Is there any question?
Yeah. My question is, did you test the accuracy of your models?
Yes, I use Google. Bismillah. Yes, I use Google.
Okay.
Yes, Google. Yes.
And how did it perform? Was it accurate? How accurate were
Yes.
they?
Yes, it's accurate. As I see, I told you here. Wait.
Okay.
Yes, Ms. Sara, I have one question. How do
Yes,
you
yes,
deal with the damaged documents? Because it might be
yes,
damaged because of
yes,
environment. So how do you
yes,
deal and what were the results? What were your observations?
yes. We do resizing the image. So if there is any damage in the corner, it will go. Also, and we do just take not all the image. We take 113 slice and feed it to the network.
And I mean, how do you deal with the damage which has happened to the text itself?
Text
To the
through the text.
manuscripts. Yeah, to your documents.
Yes, yes,
What
yes.
was
As I
the
told you, not the whole paper will be damaged. If there is a specific paper is damaged, we will take another slice from the paper, not from the damaged sections.
But have you observed this as a challenge because of some text is lost because of that damage?
Yes, yes, it is not some kind of a challenge of the historical document all, not
Yeah,
just the historical document.
okay.
Is there another question?
No more questions from me. Thank you so much. That was a great presentation. Thank you.
Thank you.
Thank you, Sarah, for your presentation. Now, as we have completed all the presentation in this session, I sincerely thank our authors for their excellent presentation and great contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough to all the authors. We, on behalf of all the team, thank you for your support during this version and uh, all previous 8 versions of this conference. We will be happy to have you all in the next version of this conference in 2026.
Thank you. Bye bye.
Thank you so
Thank you.
much.
Just a second,
Take care.
dear author. Just a second. I'll just complete the session. Just a second. All the presenters will be getting their digital certificates through email within 2 working days, right? And the present publication will be live within 7 to 8 months. So kindly cooperate with the team. WS4 2024 London, 2025 London. So just before, I also thank our session chair, both the session chair for chairing the session. And there is one token of appreciation to be a chair on behalf of Global Knowledge Research Foundation and GR Scholastic LLP. Doctor, this is for you.
Thank you.
And this will be for Swati ma'am.
Yeah, thank you so much. Thank you.
Thank you, ma'am, and thank you, sir, for your valuable presence over this for this conference. Now I request you all to turn on your camera so we can capture the good memories of this virtual conference, as I mentioned earlier in this starting of the conference. I request everyone, if it is possible, you may please turn on your camera. Okay. Thank you, everyone. Thank you so much for your presence.